Hello, my name is Juan Pablo Montoya. I am going to talk about loss on ignition as an indicator of limestone content and its impact on cement hydration. Introduction. The incorporation of limestone filler in commercial cements is becoming increasingly common. However, its presence can influence hydration behavior and affect the final properties of the cement. In this context, loss on ignition is recognized as a useful indicator for estimating the limestone content in cement. This study aims to explore the relationship between loss on ignition and the hydration behavior of various cement samples, with particular attention to the influence of limestone content on water demand and setting times. Experimental procedure. Loss on ignition tests were conducted in accordance with the procedure outlined in Mexican Standard C595 ONNC CE 2017 Figure 1A. Standard consistency was evaluated using the VCAT apparatus, following Mexican Standard C57 ONNC CE 2015 Figure 1B, while setting times were determined using the VCAT method as specified in Mexican Standard C59 ONNC CE 2017 Figure 1C. Additionally, total void percentage was measured to assess porosity. 5 commercially available Portland cements from Morelia, Michoacán, Mexico were analyzed, 3 classified as CPC30R and 2 as CPC30RRS, each exhibiting distinct compositions. This variation enabled the identification of correlations between loss on ignition values and key hydration-related properties. Results. Relevant correlations were identified in this analysis. First, a higher loss on ignition percentage is associated with a greater water demand to achieve standard consistency, which implies a more porous structure in the cementitious matrix. Figure 2. Second, although recent research by Rafael Alfredo Méndez Páramo, 2024, figure, has reported accelerated or false hydration characterized by faster initial and final setting. The results of this study suggest that both initial and final setting times tend to increase as loss on ignition increases. This behavior may be attributed to potential variations in ambient humidity and temperature conditions. Figure 4. Third, as the percentage of total voids increases, the water cement also tends to rise. Figure 5. Reinforcing the link between filler content, water demand, and microstructural development. Conclusion. The Mexican Standard C414 ONNCCE 2017 allows for the incorporation of up to 35% limestone as a component of cement, depending on the type, reflecting a more flexible approach compared to the 15% limit permitted in the United States, promoted by the Portland Cement Association, now known as the American Cement Association. However, this higher proportion of inert additions increases the water demand required to achieve standard consistency, which in turn affects the water cement and may negatively impact the porosity and performance of concrete. As proposed by Rafael Alfredo Méndez Páramo, it may be more appropriate to consider the water clinker instead of the traditional water cement, especially in cements with a low clinker content. This highlights the need to review standards such as standard test method for mechanical mixing of hydraulic cement pastes and mortars in the laboratory. Number 305, originally developed for clinker-rich cements without additions, and to adapt them to current formulations.